Lesson 13, I will reason using benchmarks to compare two fractions on the number line. In Lesson 12, we began comparing two fractions on a number line using the benchmarks 0, half, and 1. And I know that lesson was pretty tough. There was a lot of concepts about fractions that you had to understand. We're going to continue those same skills that we used in Lesson 12. The only difference is in Lesson 12, we used the benchmarks 0, half, and 1. And in this lesson, we're going to use the benchmarks 0, 1, and 2. So we're actually going to be looking at some fractions that are greater than 1 today. You're going to need your journal, and you're also going to need your practice sheet. Go ahead and get your journal ready by writing today's date. In Lesson 13, compare fractions on a number line. When you're finished with that, I want you to find this sheet. This is your practice sheet. It has several number lines already drawn on there. We will not use all of these number lines, but it'll save you the time of needing to draw a number line. You can use this practice sheet anytime it says to draw a number line instead of trying to draw one in your math journal. Okay, so the first thing I want you to do is, I know it says compare 7/8 and 6/4 with your partner, and you may not have a partner. So let's just think about this for a minute. Think about what you know about 7 out of 8 and what you know about 6 out of 4. Well, the first thing that you should think to yourself is, well, 7/8 is less than 1. It takes 8/8 to make a whole, and you only have 7. But 6/4 is greater than 1 because 4/4 makes a whole and you have more than 4. So in your math journal, we're going to draw a number bond for 6/4, partitioning the whole and its parts. So I want you to do this in your math journal. I want you to put 6/4, and then over here we're going to take the whole out, which is 4/4, and over here we're going to put what's left over. If you added these together, you would get 6/4. So by looking at this, you can tell that 6/4 is greater than 1 whole because 4/4 is 1 whole. All right, now we can use this number bond to help us locate 6/4 on the number line. So on the first number line on your practice sheet, I want you to label it from 0 to 2. So instead of labeling it from 0 to 1, I want you to label it from 0 to 2, just like this. So normally we put 0 here and 1 at the end and a half in the middle. But we're going to label this from 0 to 2, and right in the middle of 2 would be 1 or 4/4. So I want you to go ahead and put 4/4 above the 1 after you label this on the very first number line on your practice sheet. So because 6/4 is 2/4 more than 1 whole, we can imagine partitioning this line into fourths between 1 and 2. Where would you put 6/4? Well, if you take your number line and you partition it into 4 groups, just like I have this one, you can see that I drew 3 lines here. And these 3 lines make 4 parts. 1, 2, 3, 4. So this would be 4/4, 5/4, 6/4, 7/4, 8/4. So this is where 6/4 would be on the number line. So if 6/4 is greater than 1 and 7/8 is less than 1, we can think about this statement, okay? Excuse me. Let's go ahead and plot 7/8. And I'm going to change colors here because sometimes if you change the color, it will help you to be able to see the difference when you're plotting. Right now I have 4s and I want to make 8ths. So if I take each of these 4s and divide them in half like this, these 4s will become 8ths because if you look, I've got 1, 2, 3, 4, 5, 6, 7, 8 parts now. I could keep going here, but I'm not going to. So I'm trying to find 7/8. 1, 2, 3, 4, 5, 6, 7. So here is 7/8. So by looking at 7/8 on the number line compared to 6/4, now we can write a statement comparing the two fractions. So in your math journal, or if you have some room on your practice sheet, you can write it in your practice sheet. I want you to write 7/8 is less than 6/4. Okay, let's try one more before we start our practice sheet. All right, now we're going to compare the fractions 5/3 and 9/5. So in your math journal, we're going to create a number bond to represent 5/5 and 9/5. Now you'll notice first of all that 5/3 is greater than 1. I know this because first of all the numerator is greater than the denominator. It takes 3/3 to make a whole and I have 5 of them. I also notice 9/5 is greater than 1 because my numerator is greater than my denominator. It takes 5/5 to make a whole and I have 9 of them. So we're going to create 2 number bonds in our math journal. All right, we're going to start with 5/3. So I want you to put 5/3 in the middle, and then we're going to put 3/3, which equals 1 whole, and over here we would put what's left over. If I added these together, I would get 5/3, but this shows that 5/3 is 2/3 greater than 1 whole. And then we're going to do the exact same thing with 9/5. See if you can do 9/5 in a number bond by yourself. All right, hopefully you felt confident enough to try this, and you put 9/5. A whole would be 5/5, because if you have all of them, you have 5 out of 5, and then you would have 4/5 left over. So 9/5 is 4/5 greater than 1 whole, and 5/3 is 2/3 greater than 1 whole. All right, now, underneath your number bonds, we're going to rewrite these fractions as a mixed number. So instead of 3/3, we're going to put 1 whole like this. And then we're going to create a mixed number by writing this as 1 and 2/3. Here's my 1 and here's 2/3. So 5/3 is the same as 1 and 2/3. Let's do the same thing for 9/5. So 9/5 equals 1 and 4/5. This is a mixed number. Okay, it means the exact same thing as 9/5. We just, instead of writing 5/5, we wrote 1 whole. So it's like if you had a pizza. You could have 9 pieces, and it only takes 5 to make a pizza. This means you'd have more than 1 pizza. Or you could just say, hey, I've got 1 whole pizza and 4/5 of another. All right, now we're going to compare these two fractions by plotting them on a number line. Okay, the first thing I want you to do is I want you to go ahead and take a look at your second number line. I'm just going to draw it down here actually. So here's my second number line. And we're going to, again, because we're talking about fractions that are greater than 1, we're going to go ahead and label this as 0, 1, and 2. So we're going to put 0, 1, and 2. Whereas last lesson, we were just putting 0 to 1. Okay, so this time we're going to do 0, 1, and 2. Okay? All right, so how would we plot 2/3 and 4/5? Or actually 1 and 2/3 and 1 and 4/5. So first of all, we have to think about this. If it's greater than 1, then that means neither one of these fractions are going to be between 0 and 1. They're both going to be over here. So if I'm going to plot 1 and 2/3, I have to divide this into thirds. So let's do that. So now I've divided it into 1, 2, 3 parts. So here's 1 and 1/3, here's 1 and 2/3. Okay, I also have to plot 1 and 4/5. So that means I have to partition this part of the number line into 5 parts. Okay, so I would do that like all right, so let's do fifths. All right, so I'm only going to draw 4 lines. All right, so I've got 1, 2, 3, 4. Now I've got 1, 2, 3, 4, 5 parts. Now that's right. So I've got 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5. I'm going to write this above so you can see it a little bit better. It doesn't get mixed up. So here's 1 and 2/3. Here's 1 and 4/5. Okay? All right, now this is the exact same model, except instead of calling it 1 and 2/3, it's 1 and 5/3, or excuse me, 5/3. So I'm going to write it up here. So 1 and 2/3 is the same thing as 5/3. 1 and 4/5 is the same thing as 9/5. So now we can write a comparison symbol or a comparison statement. We can say 5/3 is less than 9/5. You can write this on your practice sheet or in your math journal. Or we can say 1 and 2/3 is less than 1 and 4/5. It means the same exact thing. This is just the fraction written as an improper fraction with a larger numerator than a denominator, and this is the fraction written as a mixed number, but it means the same thing. All right, so let's go ahead and take a look at our problem set. First of all, I want you to understand that I am aware that what we are doing right now is much more difficult than what you did in the beginning lessons of fractions. And this is where you start to get a little bit more into 4th grade math. It is a little bit tricky, but I want you to hang in there and do your very best. Don't panic if you don't understand. You may have to listen to an explanation more than once. That's why it's nice that you can rewind the video. All right, so the first thing we're going to do is we are going to plot these fractions. Now, I want you to notice that on this number line, it does not start at 0. This number line actually starts at 1. And the reason why they did that is because on our practice sheet, if you noticed, when we were labeling our number sentences or plotting our fractions, we never used the area between 0 and 1. We left it blank every time. So by taking this number line and just leaving off the 0 and starting at 1, you have more room to create your fractions. But what you have to realize is that this is a whole now. On what we did in our journal, this was a whole and this was a whole. But now on this number line, this is the whole. Okay, so that's going to be really important because that's going to change the way that we partition this number line. Okay, so let's get started here. First of all, we have 4/3. So let's think about this for a minute. 4/3, if you created a number bond here, you would have 4/3. Notice how I'm doing this really small. I've got 4/3, and then I'm going to separate this into a whole and its parts. So my whole would be 3/3. I know that's hard for you to read. Let me try this a little bit different. 3/3, and then I would have 1/3. So what that means is 4/3 is the same as 1 and 1/3. So right here I would have 3/3. 1 is the same as 3/3. So if I'm trying to show 4/3, I have to partition this entire thing into 3 parts like this. These are going to be big parts. So I've got 1, 2, 3. So if this is 3/3, then this would be 4/3. All right, so now we're going to do 6s. So how many 6s are in a whole? That would be 6 6s. So underneath the whole, I'm going to go ahead and put this as 6 6s. And I'm trying to go to 11 6s. So I'm going to switch colors here. If these are thirds, and I already have it divided into 1, 2, 3 parts, then if I divide each third in half like this one already has one right here, then now I have 6 parts. 1, 2, 3, 4, 5, 6. So if this is 6 6s, then this is 7 6, 8 6, 9 6, 10 6, 11 6. 11 6. All right, so now I'm going to do 17 12ths. So how many 12ths would be in a whole? You would have to have 12 out of 12 to have the whole whatever, the whole pie, the whole cake, the whole whatever. All right, so I've got 3/3, 6 6. Well, this time this is going to be 12 12. So I'm going to change colors again here so you can see a little bit better. All right, so if this is 12 12ths, these are 6s. So if I have 6 parts and I need 12, all I have to do is divide each 6 into half, and now I will have 12 parts. So we can go through and count and make sure that there are 12 parts. But let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So this is 12 12ths, 13 12ths, 14 12ths, 15 12ths, 16 12ths, 17 twelfths. Okay, so I'm pretty sure that there is a mistake here because when I'm looking at this, there is no 1 and 3/12. There's only a 1 and 5/12. So the first thing I want you to do is I want you to go ahead and I want you to mark this out and I want you to change this to 1 and 1/3. Okay? All right, so we're going to compare 1 and 5/6 to 1 and 1/3. So remember 1 and 5/6 is the same thing as 11 sixes, and 1 and 1/3 is the same thing as 4 thirds. So let's take a look at our number line. Here's 4 thirds, and here's 11 sixths. So as you can tell by the numbers line, 11 sixths is greater than 4 thirds. Now let's take a look at B. It says 1 and 1/3, which remember is the same thing as 4 thirds, and we're comparing that to 1 and 5/12, which is the same thing as 17/12. Well, you can tell on the number line that 4 thirds comes before 17/12, so 4 thirds is actually less than 17/12. All right, let's take a look at number 3. Now we're going to plot 11 eighths, 7 fourths, and 15/12 on the number line. Again, I want you to notice that the number line begins at 1 and it ends at 2. All of our fractions are greater than 1. So if you look at 11 eighths, how many eighths does it take to make a whole? It takes 8 eighths. So we can say, okay, I've got 8 eighths, and then I have 3 eighths left over. So 11 eighths is the same thing as 1 and 3 eighths. And 7 fourths. It takes 4 fourths to make a whole, and then I have 3 fourths left over because when you add these together, you have 7 fourths. So 7 fourths equals 1 and 3 fourths. And then 15/12. It takes 12 twelfths to make a whole, and then I would have 3 left over. So 15/12 is the same as 1 and 3 twelfths. So all of these are going to come between 1 and 2 because they are greater than 1. So remember, this is my whole here, 1 whole. So if I were looking at this as a tape diagram, all of these would have 1 whole. All 3 of these fractions would have 1 whole, and then they would have some over here. Okay, so that's why on our number line, if we started it at 0, here would be 1, and we wouldn't do any partitioning here. All of our partitioning would be between 1 and 2. So what we've done is we've just eliminated this part, and we are only looking at between 1 and 2. It just makes this number line a lot bigger and easier to work with. All right, so let's start with 1 and 3 eighths. So my number line has already been partitioned into 1, 2, 3, 4 parts. So I could go ahead and easily plot 1 and 3 fourths because here is 1, here is 1 and 1/4, 1 and 2 fourths, 1 and 3 fourths. So I'm going to go ahead and put 1 and 3 fourths right here because it's already partitioned into fourths. Now I'm going to go back and do 1 and 3 eighths. If these are fourths, then if I divide them in half, they now become eighths. So this would be 1, this would be 1 and 1/8, 1 and 2 eighths, 1 and 3 eighths. All right, lastly, if I take a look at my fourths, just go back to the fourths here for a second. If I divide each of these fourths into 3 parts like this, they will become twelfths. Okay, we're going to go back and count just between the fourths and the red line. So you see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was basically just ignoring the eighths and only looking at the twelfths and the fourths. So this is 1. This is 1 and 1/12, 1 and 2/12, 1 and 3 twelfths. So now it says use the number line in problem 3 to explain the reasoning you used when determining 11 eighths or 5 twelfths is greater. So let's take a look. Is 11 eighths or is 5 twelfths greater? Well, 11 eighths, I'm going to go ahead and write that up here. That's the same as 1 and 3 eighths. So I've got 11 eighths, and 15 twelfths is the same thing as 1 and 3 twelfths. So how can we determine which is greater by using the number line? Well, that's pretty easy, right? I'm going to type this because I can type faster than I can write. So we'll say 11/8 is greater because it is closer to 2 on the number line. When you look at the number line, once you put them on the number line, whichever one's closer to the larger number is bigger. You also could have said that 15/12 is less because it's closer to 1. Okay? All right, so let's take a look at number 5. This is just like the back of lesson 12. And I remember what we talked about in lesson 12, that it's real easy for boys and girls to see less than and greater than and just say, hey, I'm just going to guess because I've got a 50-50 chance. And that's why if you just put greater than or less than, even if you get it right, I will not count it right. I need the explanation. Now on this one, I'm probably going to go ahead and draw number lines just like I did on the last one, just because that can count as our explanation. All right, so I've got 3/8, and I'm comparing it to 7/12. So if I put that on a number line, let's think about this for a minute, okay? We don't have to go through and partition this whole entire number line into eighths and into 12s, because when I look at this, first of all, both of these are less than 1. I know that because it takes 8 out of 8 to make a whole and 12 out of 12 to make a whole. And neither one of these are greater than 1. So I'm going to think about the half benchmark. How much eighths does it take to make half? Well, it takes 4/8. So 3/8 is less than half. So I would have 3/8 here. Well, let's look at 12s. How many 12s does it take to make half? Well, it takes 6/12 to make half, but I have 7/12. So that means that 7/12 is greater than 1/2. So see how I could plot these by using the benchmark 1/2 without dividing this into eighths and 12s, because I know that 3/8 is less than half and 7/12 is greater than 1/2. Therefore, 3/8 is less than 7/12. All right, so let's take a look at B. Again, the first thing I'm going to think to myself is are either of these fractions greater than 1? And because 5 is less than 12, I know this is less than 1 whole. And because 7 is less than 8, I know that that is less than 1 whole. So when I draw my number line, I only have to go from 0 to 1 because both of these are less than 1. So when I plot 5/12, I'm going to compare this to 1/2. How many 12s does it take to make half? Well, half of 12 is 6. So 6/12 would be half. Well, I only have 5. So that tells me that 5/12 is less than 1/2. And what about 7/8? It's almost a whole, isn't it? Because it takes 8/8 to make a whole. So when I plot 7/8, I know it's going to be close to 1 because 1 is the same as 8/8. So now I can compare these two fractions. 5/12 is less than 7/8. I can tell by looking at my number line. Okay, now let's take a look at these two fractions. Now, 8 is greater than 6. So first of all, I know that this fraction is greater than 1. 11 is less than 12. So I know that this fraction is less than 1. So look at this number line. So if I have 0, 1, and 2, I know that 11/12 is less than 1. And I know that 8/6 is greater than 1. That's all I need to know. I don't have to divide this number line into 8s and 12s. I can take a look right here and see that 11/12 comes before 8/6. So 8/6 is greater than 11/12. All right, so let's take a look at 5/12 and 1/3. All right, 5 is less than 12, so I know that this fraction is less than 1, and 1 is less than 3, so both of these fractions are less than 1. So my number line is going to be from 0 to 1. Now 1/3 is going to be pretty easy. If I divide this into thirds, then I'm going to be able to do 1/3. That's pretty easy. So here's 1/3. Now I've got 5/12. So what would it make to be half? Half of 12 would be 6. So 5/12 is almost 1/2. Not quite, but almost 1/2. So that tells me that 1/3 comes before 5/12 on the number line. So 5/12 is greater than 1/3. All right, let's take a look at E. So now if I have 7/5, 7/5 is greater than 1 whole because 5 out of 5 would be 1 whole, and 11/10 is greater than 1 whole. Okay, so let's take a look here at this for a minute. Because both of these fractions are greater than 1, I'm going to label my number line from 1 to 2. Okay, I'm going to divide this number line into fifths like this. 1, 2, 3, 4. So I have 1, 2, 3, 4, 5 parts. So 7/5. This is 5/5, 6/5, 7/5. Okay, so if these are fifths and I want to make tenths, all I've got to do is divide them in half. I'm going to use a different color here just to help you see. So I'm going to divide all of these fifths in half, and now I have tenths. So I've got 10/10, 11/10 right here. So which one comes first? 11/10. So that tells me that 7/5 is actually greater than 11/10. All right, so let's take a look at F. I've got 5 out of 4. This fraction is greater than 1. I have 7 out of 8. This fraction is less than 1. Knowing that, I don't have to do too much drawing on my number line, but I am going to go ahead and make this 0, 1, and 2. 7/8 is less than 1. 5/4 is greater than 1. That's all I need to know. If 5/4 is greater than 1 and 7/8 is less than 1, then 7/4 has to be greater than 7/8. All right, so let's take a look at G. 13/12 is greater than 1 because 12/12 makes a whole. 9/10 is less than 1 because it takes 10/10 to make a whole. So I could write that out in a sentence, but I think it's just as easy to go ahead and show this on a number line. So I'm going to go ahead and make my number line 0, 1, and 2. 13/12 is greater than 1 because 12/12 makes a whole. 9/10 is less than 1 because 10/10 makes a whole. So 13/12 is greater than 9/10. Okay, let's look at H. 8/8 makes a whole, so 6/8 is less than 1. 5/4 is greater than 1 because 4/4 makes a whole. So the last three have been very similar. So I'm going to do 0, 1, and 2. 6/8 is less than 1. 5/4 is greater than 1. So 6/8 is less than 5/4. I don't expect them to all be that easy, but it's nice that those were. All right, so let's take a look at I. 8/12 is less than 1 because it takes 12/12 to make a whole. 8/4 is greater than 1. So let's take a look at this one. This is just like the last three that we just did. So I'm going to do 0, 1, and 2. 8/12 is less than 1. 8/4 is greater than 1. So 8/12 is less than 8/4. All right, last problem. So now I have 7 out of 5. So this is greater than 1 because 5/5 makes a whole. And I have 16/10, and this is greater than 1 because 10/10 makes a whole. So this one's not going to be as easy as the last three, or 4 actually. Because both of these are greater than 1, I'm going to make my number line from 1 to 2. Because these are fifths, I'm going to partition this into fifths. 1, 2, 3, 4 lines makes 1, 2, 3, 4, 5 parts. So this is 5/5, 6/5, 7/5. Now to make tenths is going to be pretty easy because if I already have fifths and I want to make 10 parts, all I have to do is divide all of my fifths into halves just like this. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So this would be 10 tenths, 11 tenths, 12 tenths, 13 tenths, 14 tenths, 15 tenths, 16 tenths. So now by looking at the number line, we can tell which is the greater fraction. 7/5 comes before 16 tenths, so it is less than. So let me end this lesson by saying there was a lot of information in this lesson. You had to understand a lot about fractions to be able to compare fractions using a number line. The last two lessons have been very tough. So please be easy on yourself if you're having a hard time understanding. Don't give up. Keep going back and looking. You may have to come back and listen to the explanation to some of these fractions to be able to understand and do some of this on your own.